Hi guys, so today we're going to be looking at 5.5, performing function operations. There are going to be 1, 2, 3, 4 different operations that we're going to be completing. For the addition operation, if we have a function that's adding with another function, we can separate them into two different functions and add them together. Same thing goes for subtracting, multiplying, and dividing. All we're doing is just separating them into two different functions where we're going to be adding, subtracting, multiplying, or dividing. So let's say, for example, we're adding two functions. For example, let 3 times square root of x and g of x equaling to negative 10 times the square root of x. We're going to be using those two functions, and we're going to find f plus g of x and then state the domain. Then we're going to evaluate the sum of x equaling to 4. So if I'm going to do this, first step that I need to take here is I have my f plus g of x, and the rules that we can separate them as f of x and g of x. So I'll separate this as f of x adding with g of x. And I know that my f of x is equal to 3 times the square root of x. So I'll drop that down as my 3 square root of x. And then for my g of x, I know that's supposed to equal to negative 10 square root of x. So I drop that right here. Once I do that, I'm just going to be simplifying. So if I have 3 times square root of x and negative 10 times the square root of x, I can combine them together. The positive and the negative turns into a negative sign. And since they have the same square roots, I can combine them as like terms or like roots. So 3 minus 10 equals to negative 7 square root of x. Once I do that, I can identify and state the domain. So I do know that for the domain of a square root, if I were to just sketch an image of negative 7 square root of x, I know that that would be going down here and it would continue on to the right, because number one, we have a negative sign, so that's going to flip my image from being on the top. And since it's a square root, originally it looks like this, but being flipped, it's going to be down here instead. And so I can identify what my domain is because it starts at 0 and it continues to go to the right. So we can just say that the domain is all negative real numbers. And basically all that means it's all the numbers that are greater than x. If you want to just write down instead x being greater than or equal to 0, that works too. Either way works. Okay. All right, the last part is asking us to evaluate when the sum of x is equal to 4. So if we have our f plus g statement, and I'm substituting for 4, all I'm going to do is take my answer that I got from my original problem, and I'm going to substitute the x for 4. So when I do that, I get my answer, which is going to be negative 7 times 2, and that equals to negative 14. That would be my final answer. Okay, let's try out the next one. Next one is subtracting two functions. We have here f of x equaling to 3x to the power 3 minus 2x plus 5, and we also have here g of x, x to the power 3 minus 3x squared plus 4x minus 2, and we're supposed to find f minus g of x, and then afterwards state the domain, then also identify what or evaluate when we have x equaling negative 2. So again, if we have here f minus g of x, I can change this into being f of x minus g of x. And so when I substitute that in, I get 3x to the power 3 minus 2x squared plus 5, and that's subtracting with the other function, x to the power 3 minus 3x squared plus 4x minus 2. So before I do anything, we have a negative sign that I do have to distribute to every single term. So I'll distribute that negative sign to my x to the power 3, negative 3x squared, 4x, and to my negative 2 here. When I do that, I get left with negative x to the power 3 plus 3x squared minus 4x plus 2. And on the bottom, I could just combine the like terms with each other and align them. I know that 3x to the power 3, that's going to go underneath the negative x to the power 3. The negative 2x is going to go underneath the 3x. And the positive 5 is going underneath the positive 2. From there, I could just combine it. So we get here positive 2x to the power 3 minus x squared minus 4x plus 7. And then from there, we get our final simplified answer. So if I was going to identify the domain of this, I always want to look at the highest degree, which is the 3 here. And if the highest degree is 3, I know that if I were to sketch this out, the idea is that it could go anywhere really, where it could go either on the top or it can go on the bottom. So there's not really any restriction for x to the power 3. You could have an odd number, even number, doesn't really matter. So I know that any of our x values can be positive or negative, which means that we get a domain which is all real numbers. Doesn't really matter what number we choose. Okay. And then the last part, evaluate the difference when x is equal to negative 2. So I'll take my function f minus g and substitute it for negative 2. So I'll take my new equation, which is 2 times negative 2 to the power 3 minus negative 2 to the power 2 minus 4 times negative 2 plus 7, and solve that out. We get negative 8, and times 2 is negative 16. This becomes negative 4, positive 8, and 7. And then we get negative 20, positive 15, so we get our answer negative 5 in the end, and that would be the final answer. Okay, multiplying two functions. So if I'm multiplying two functions, we have here x to the power 2, and we also have here square root of x. We want to state the domain and then evaluate when x is equal to 9. So again, if I have f times g of x, then I'm multiplying f of x times g of x. And so I can write here x to the power 2 times the square root of x. And from here, it doesn't look like we can do anything, but what I can do though is I can rewrite this into an exponential form of 1 over 2. And if I do that, I can identify here, since they have the same base, that I could add my exponents together. So 2 over 1 plus 1 over 2. That gives us, I need to multiply this by 2. If I do that, I get 4 over 2 plus 1 over 2, which ends up being x 5 over 2. And so if you want to rewrite it into the square root form, you could. So I get here square root of x to the power of 5 in the end. And I do know that domains for anything that's a square root that's even means that I can't have a domain where my x value is going to be a negative number. So I know here that my domain has to be all numbers that are greater than or equal to 0. They all have to be positive or the number 0. Once I do that, then I can evaluate the product of x equaling to 9. So fg of 9 turns into the square root of 9 to the power of 5. And then square root of 9 is just 3. 3 to the power of 5. 3 to the power of 5, that equals 243. Done. All right. Dividing two functions. So if I'm dividing two functions, let's say we have here f of x equals to 6x, g of x equals to x to the power of 3 over 4, and they're telling us to divide it this time. Then afterwards, evaluate when we have x equaling to 16. So if I have here f of g of x, then I could separate it as f of x dividing with g of x. And that becomes 6x dividing with x to the power 3 over 4. And since we have two x's with the same base, I can combine them together. This would be imaginary 1, and so I can subtract them with each other. I can combine those x's and we get here 1 minus 3 over 4, which equals to 6x to the power of 1 over 4. And so again, if I were to rewrite this into the root format, we would get here 4 root x. So because we have an even root, I can't say that I can have a negative number in here. If I do that and I had, like, let's say negative 16, it wouldn't work out. There's no numbers, no solution. So I have to say that all my values again have to be greater than or equal to 0. And then once I do that, I can start solving and evaluating. So f divided by g of 16. I'm going to substitute the 16 into the formula. So 16 goes inside the root, and we get 6 times 2, which is equal to 12. That would be my final answer. So we went through all 4 operations. So let's say that we have a word problem or a real-life situation. For a white rhino heart, R, in beats per minute, and lifespan, S, in minutes, are related to the body mass, M, in kilograms by the function of negative 0.25. And from here, our R of M is equal to 241 M, and my S of M is equal to 6 times 10 to the power of 6 times M to the power of 0.2. If you don't remember, this is what we call scientific notation. So if you really want to expand this, you could always rewrite it as 6, 1, 2, 3, 4, 5, 6. So you could always write it that way, but it's kind of annoying to write that many zeros all the time. So often I like to just rewrite it into that scientific notation instead. And so what they're asking us to do is to multiply those two, the R and the s of m and see what we get. And so from here, r times s of m can be separated as r of m times s of m, and then that turns into 241m to the power of negative 0.25. That's multiplying with my 6 times 10 to the power 6 m to the power of 0.2. And so from here I can separate my 204 and my other 6 times 10 to the power of 6 together. So I can multiply that together first. 6 times 10 to the power of 6. And on the other side, I can multiply my m to the power of negative 0.25 with my m to the power of 0.2. So let's see, 241 times 6, that equals to, let's see, 241 times 6 equals to 1,446 times that 10 to the power of x, 10 to the power of 6. And just a reminder, whenever you're dealing with scientific notation, they always want the decimal to be on the first point. So if there is like more than one number, you always want the decimal to be there. So I'm moving that decimal 1, 2, 3 spaces. So I need to add 3 to the 6. So we get here instead 1.446, 1.446 times 10 to the power of 9. And on the other side, I'm multiplying this by m, and those are adding with each other, so negative 0.25 plus 0.2, that equals to m to the power of negative 0.05. And so that would be my final answer, where I have my scientific notation of 1.446 times 10 to the power 9, and it's multiplying with m to the power of negative 0.05. So hopefully this helped. Good luck.